Assalamualaikum dan salam sejahtera semua. So, video ni kita akan masuk subtopik baru iaitu 6.0 Chemical Equilibrium, keseimbangan kimia untuk week 14 third hour. Okay, so kita akan start with the 6.1 Dynamic Equilibrium. Okay, first of all, what students should know in this subtopic? Okay, students should able to explain a reversible reaction, dynamic equilibrium and law of the mass action, and state the characteristic for the system in equilibrium. So soalan ni selalunya akan keluar characteristic for the equilibrium system, and explain the change in concentration of the reactant and product based on the curve of the concentration versus time for the reversible reaction. Okay, so kita start dengan yang pertama. What is mean by the reversible reaction? Okay, basically yang sebelum ni kita belajar adalah non-reversible reaction. Okay, sebelum masuk topik 6 kita belajar semua adalah tindak balas tidak berbalik. Non-reversible reaction adalah tindak balas tidak berbalik. Okay, non-reversible reaction means the chemical reaction proceed in only one direction. Okay, such as A react with B, produce C and D as the product. Okay, for the reversible reaction, reaction which take place in both forward and reverse direction. As example, A react with B to produce C and D. Once C and D produce or once C and D form, it will form A and B. Okay. Okay, anak panah ke hadapan. Okay, reversible arrow maksudnya anak panah pergi dan balik. Anak panah pergi ni for A plus B produce C plus D. While the reverse arrow here refer to the reverse reaction, which is C reacting with D produce A plus B. Okay. As example, for the non-reversible reaction, combustion of carbon. So, carbon solid combusted in oxygen gas produce carbon dioxide. Okay. Ini yang diterangkan tadi ya. Forward reaction adalah forward arrow, which is the reaction proceed from the left to the right, iaitu from A react with B to form C plus D. While the reverse arrow for the reverse reaction, which is reaction proceed from the right to the left, which is C and D reacting to form A plus B. Okay. So, ini contoh penggunaan reversible arrow. Reversible arrow maksudnya, okay, forward arrow which is refer to the A produce B. While reverse arrow to show the B produce A. Okay. So, in a reversible reaction, initially the reaction proceeds toward the formation of the product. As soon as some product molecules form, the reverse process begins to take place. Ni yang tadi madam kata, reactant molecules are formed from product molecule. Maksudnya produk yang akan bentuk reactant bila B dah terbentuk daripada first reaction. Okay, so consider the following reversible reaction. A produce B. Once B form, B will form A. So, A as the reactant at initially, while B is product formed after reaction proceed. Okay. So, the graph of the concentration of A and B against time. That means graph ini, y-axis refer to the concentration of A and B. Time is the x-axis. So, contoh nak lukis. Okay, katakanlah this one is the y-axis. Oh, saya ingat pula. Sorry. Okay. So, let's say this one is the y-axis. Salah saya ingat je ni. Okay, label as concentration. The unit of the concentration is molar. while as this is the time. Katakanlah time recorded in second unit. Doesn't matter lah So, at initially, pada permulaan tindak balas iaitu T sama dengan kosong. Pada masa T sama dengan kosong. So, what species exists in the container? Pada permulaan eksperimen, apakah yang wujud dalam bekas tu? Reaktan ke produk? For sure lah, reaktan yang ada dalam bekas tu. Produk belum terbentuk lagi kan? So, initially, ada concentration of A. Let's say lah concentration of A initially is 1.0 molar. Katakanlah, ni adalah 1.0 molar is the concentration of A at T sama kosong. While concentration of B initially, permulaan eksperimen, ada tak B ni terbentuk dalam kita punya bekas? Tak ada lagi. So, 0.0 molar. So, kita punya concentration of B is 0.0 molar at this point. So, when reaction take place, apabila tindak balas mengambil tempat, maksudnya bertindak balas bahan-bahan awak ni, so A akan berkurang. The concentration of A will decrease with time. Kenapa concentration of A decrease? Because A form B. So, maksudnya concentration of A berkurang. So, dia akan bergerak ke atas ke bawah. So, daripada 1.0 dia akan bergerak ke bawah. Manakala concentration of B will increase with time because B will form. B is the product. Betul? Okey, seterusnya samalah. Katakanlah ni adalah 10 saat yang pertama. So, kita tengok pula 20 saat yang lepas 20 saat apa yang berlaku. So, concentration of A keep decrease while concentration of B keep increase. Betul? Okey. Let's say the equilibrium is achieved. Ingat kita punya reaction is the reversible reaction. So, reversible reaction will achieve equilibrium. Let's say lah at T equals to 20 second, equilibrium is achieved. Ni adalah at equilibrium. So, what happened at equilibrium? After T1, the concentration of A and concentration of B remain unchanged. Let's say T1 kita ni lah 20 saat. So, apa yang berlaku? Concentration of A and B remain unchanged. Maksudnya, concentration awak kat A awak sini. So, dia akan bergerak ke tidak? Tak. Dia punya nilai tu constant value. Straight line lah. Takkan terus berkurang dah. Dia akan remain unchanged. Same for the concentration of B. Remain unchanged. So, biarlah dia berapa lama pun. 30 saat, 40 saat, 50 saat, 60 saat. Kenapa concentration tak berubah selepas 20 saat, 30 saat, 40 saat, 50 saat? Sebab dia dah achieve equilibrium. The system is in the state of the equilibrium after T1. Why? Because the concentration of A and B remain unchanged. Concentration dia kekal pada satu nilai sahaja, dah tak berubah. Tapi tindak balas tidak stop The reaction still take place but the concentration remain unchanged. Why? Ni kita tengok nanti. Kenapa kepekatan reaktan dan produk tidak berubah tetapi tindak balas masih lagi berlaku? Okey, so kita tengok what is mean by the equilibrium. Okey. Seterusnya kita tengok equilibrium. What is mean the equilibrium? A state in which there are no observable changes as time goes. Okay. As time goes by. Kenapa no observable changes? Because the concentration of reactant and concentration of product remain unchanged. Ni. The concentration of reactant and product remain constant over the time. There are no visible changes in the system. Okay. They have two type of equilibrium, which is the physical equilibrium. Physical equilibrium yang kita dalam 5.4 tadi tu. Dan juga chemical equilibrium. Chemical equilibrium dalam topik 6. Ingat lagi tak masa topik 5.4 kita belajar physical equilibrium di mana kita ada solid and liquid in equilibrium. Kita ada solid and gas in equilibrium. Dan kita ada liquid and gas in equilibrium. Kita ada three curve in the phase diagram. What is mean by the equilibrium in the phase diagram? Ingat lagi tak topik 5.4 hari tu? which is the rate for the formation of solid and rate the formation of liquid at same rate. Same for the solid in equilibrium with the gas. So the rate for the formation of gas are equal to the rate for the formation of the solid. Itu maksud equilibrium. Kadar pembentukan dia, rate are equal. Sama juga untuk kita punya topik 6 ni. Kenapa concentration of reactant and product remain constant over the time? Because the rate formation of reactant is equals to the rate formation of product. Itu kita masukkan dengan chemical equilibrium sebenarnya. Kadar pembentukan reactant dan kadar pembentukan produk adalah pada kadar yang sama. So what is mean by the dynamic equilibrium? The reaction is said to be in a state of dynamic equilibrium when the first one, the concentration of reactant and product stop changing, which is remain constant. The concentration dia tidak berubah over the time. Why? Because the rate for the forward reaction is equal to the rate for the reverse reaction. Ni maksudnya rate forward reaction ni maksudnya rate for the formation of the product is equals to the rate for the reverse. Rate for the reverse is the rate for the formation of the reactant. Boleh tu karakteristik dia. Okey, di mana rate forward is equals to rate for the reverse reaction. Rate forward ni which is refer to the rate for the formation of the product, while the rate for the reverse reaction is refer to the rate for the formation of the reactant. Boleh? So at this time, at this dynamic equilibrium, the reaction quotient Q symbol equals to the equilibrium constant K. Q equals to Kc. This one kita akan tengok dalam subtopik 6.2 lebih detail. Okay. So this one is the characteristic of dynamic equilibrium. Kalau soalan tanya, what is the characteristic of the dynamic equilibrium? So ada 3 karakteristik of dynamic equilibrium. Yang pertama, the concentration of the reactant and product stop changing. Yang kedua, the rate for the forward reaction, which is the formation of the product, is equal to the rate for the reverse reaction, which is the rate for the formation of the reactant. And the last one, the reaction quotient is equal to the equilibrium constant ataupun simbol dia Q equals to K. Ini ciri-ciri bagi dynamic equilibrium. So keep in mind, let's say lah kita ada tindak balas N2O4 gases produce NO2 gases. At the same time, NO2 gases will form N2O4 until the system achieve equilibrium. So the graph for the change in concentration versus time same as the previous explanation, which is the dynamic equilibrium is achieved after T1. Means that after T1, the reaction did not stop. Okay, selepas T1 ni jangan cakap tak ada tindak balas berlaku. Tindak balas masih berlaku lagi. N2O4 masih lagi bertindak balas membentuk NO2. Dan NO2 pun masih lagi bertindak balas membentuk N2O4 after T1. But the rate for the forward and rate for the reverse occur at the same rate. That's why lah, the concentration of N2O4 and NO2 remain unchanged. Tengok ni, after T1 awak kan NO2 awak concentration dia sama. N2O4 pun concentration dia sama. Walaupun T dia dah berubah. Okay? So what is the law of the mass action? Law of the mass action, also known as the law of the chemical equilibrium, which is relationship between the chemical equation with the equilibrium constant. So kita akan relatekan kita punya persamaan kimia dengan equilibrium constant. So to write the K, untuk menentukan nilai K, to determine the value of K mesti depends on the chemical equilibrium. Kalau pelajar tak boleh nak tentukan chemical equation dia, so pelajar tak boleh nak tentukan nilai K. Nanti awak kena kira equilibrium constant value K awak, which is the law of the mass action state that for a reversible reaction of the equilibrium and a constant temperature, a certain ratio of the reactant and product concentration has a constant value of K. Dengan syarat at constant temperature Mesti suhu yang dikekalkan. Kalau kita change the temperature, for sure the K will change. Dengan syarat temperature constant. Baru kita akan dapat constant value for the K, iaitu equilibrium constant. Kalau temperature berubah, awak takkan dapat equilibrium constant. Okay, so law of the mass action. Let's say lah, the chemical equation is A mole of A react with the B mole of B produce C mole of C and D mole of D. Okay, after C and D form, so dia akan reacting to form A and B until the equilibrium is achieved. Okay, so at equilibrium K is equals to, okay, sebenarnya formula untuk K awak ni untuk senang hafal. Ni untuk senang hafal ni, tapi kalau jawab ni salah. Mesti jawab dalam bentuk K yang warna hitam ni. Ni cara nak jawab. Tapi formula yang senang kita nak hafal lah. K sama dengan product, concentration of product to the power of coefficient in the product divide by concentration of reactant to the power of reactant. Okay. Yang ni, kuasa dia ni, C, D, A, B ni depends on the stoichiometric equation. Stoichiometric coefficient ni menentukan stoichiometric coefficient yang ada pada chemical equation awak ni akan menentukan kuasa dia berapa. Okay, so K refer to the equilibrium constant. Bracket bucu tajam. Bracket ni kita panggil dia lah concentration of A. Cara baca apa? Concentration. How to read this symbol? Concentration. Simbol bracket ni concentration. Kalau dalam ni adalah concentration. Kalau dia tulis ni H2. So adalah concentration of H2 gas. Kalau bracket ni bermaksud concentration. Contoh saya letak dalam tu adalah NH3. So adalah concentration of NH3. Kita baca. Cara nak baca dia concentration of H2, concentration of NH3. Sama dengan cara baca kat sini lah. K sama dengan concentration of C to the power of C multiple by concentration of D to the power of D. Kuasa yang ada pada concentration ni depends on the stoichiometric coefficient from the chemical equation. Okay, A, B, C, D refer to the stoichiometric coefficient for the reacting species of A, B, C, and D. Alright. So, yang ni baca sendiri bawah ni lah. Ni dah mention dah. Amira dah mention dah. Although the concentration may vary, as long as a given reaction is at equilibrium and the temperature does not change, dengan syarat suhu tidak berubah So, the K will remain unchanged. Walaupun kita ubah concentration, tapi K value will remain unchanged unless if we change the temperature of the system. So, the value of K will change. Okay, so dah habis dah 6.1. 6.1 ni just introduction for the chemical equilibrium sebenarnya. Alright, terima kasih. Teruskan dengan 6.2 ya.